Expanding the binomial theorem and use it to find roots of numbers is what we are going to see today. Please don't forget to subscribe to the channel. Okay, start with, look here. The moment we start we are getting roots, it means that if you see a cube root, it means that we are going to deal with cube numbers, reciprocals of cube numbers. When you say square root, it means that we are going to deal with reciprocals of square numbers. To get the roots, as we are going to see in this lesson. So, expand this up the term in x squared, hence use it evaluate the cube root of 24 to two decimal places. First of all, we have seen how to expand. Now let us expand this first. So we have 1 minus 3x power third. So see that now x is this, n is that. So we have 1 plus our n. So that our n is our third. Then our x is negative 3x with its sign. Then plus our n is our third. Then n our third minus 1. Then negative 3x squared, the whole over 2 factorial plus other terms. So that's the end of the term in x squared. So now let us simplify this and see. This will be 1 minus 3x power third equaling 2. You see this third is going to cancel with that 3. So this will be 1 minus x. So negative surviving. Then here we have plus. This is 2 factorial is the 2. So you remember it as a half. It will be 1 over 2 into a third. Then this one, you simplify this, we get negative 2 over 3. When you square the negative, we get 9. Then x squared, then plus other terms. So this will be now equal to 1 minus x. Now, when you look at this 2 is going to cancel this. These 3's are going to go with this 9, so it remains the only negative x. So we have negative x plus other terms. Now, they are asking us, let's find the cube root of 24. Whenever it's here, a cube root, you deal with the reciprocal of new number. So we have the cube 1 over, the first cube number is 1. Then the next is 2 cubed, which is, its reciprocal is 1 over 8. The cube root, the cube of 3 is 27. This reciprocal is 27. The next is 1 over 64, and so on. So these are the cube numbers we have to deal with. Now, with this, which value do you need for x? We need the value of x that we put here, and it gives us 24. So of these ones, what do you think? You see this one, and when we put it here, I think we see that we test with x equaling to 1 over 27. When I put here, when my x is equal to 1 over 27. Whenever I do this, you are getting a cube root. First do the reciprocals of cube numbers. Okay, so when I put it here, I'm remaining with 1 minus 3 over 27, the whole power third equaling to 1 minus. Now where is x? I put 1 over 27. Power 2. Then this one, now we are going to see how we handle this. Now, when I multiply this and this, I'll be having now 27 minus 3 over 27 power third equaling 2. When you simplify this on a calculator, you get I'm putting all of this on the calculator. So here I'm getting 0.9616 for the small person. Now, here we are going to use this. We show that this is an approximate value because we are not giving all, then we can use this positive. Now, from here, you see that this will give me cube roots of 24 over the cube roots of 27, approximating to 0.9616. Now you see, this cube roots of 24 will be approximating now to 3. Cube root of this is 3. Then times, this is 0.9616. 0.616. And so now my cube root of 24 will be, we will now approximate. Why am I approximating? Because it's not accurate. All the values are not included. So here, they are getting me 2 decimal places. I'm getting 2.88 to 2 decimal places. This is the answer I'm getting. When we come to this, we expand on the first 3 terms. First 3 terms, it means we are dealing with up to x squared. So now we expand this now. Now I have 1 minus x over 3, now power half. This will be 1 plus our n. Our n is c, is our half, into our x. Now this is our x, negative x over 3. Then plus our n, we are putting in this formula. Our n is a half into, now a half minus 1. Then x, our x is negative x over 3, the whole squared plus other terms. The first 3 terms, 1, 2, 3, as simple as that. Let us simplify and see. The whole of this is over 2 factorial. This one is 1 factorial. Okay, this will be now 1 minus x over 3 power half equaling to 1. You see this negative is going to give us negative x over 6. Then here, I'm going to be having plus a half into negative a half. Then this one, 2 factorial is the half we are talking about. This is a half, this is a half, and also 2 factorial. Okay, let me, when you square this, you get x squared. When you square 3, you get 9. Then times this 2 factorial, which is 1 over half plus other terms. Add. Simplify this. Our half is going to be 1 minus x over 6. Is there anything that cancels? No. The negative surviving, x squared over, this is going to be, I think, 8 times 9. This is 2 times 4 times 2. That's 8 times 9, that is 72, plus other terms coming. So, that's how we expand that up the term. Okay, let me use this as 2. So we can add those terms. Okay, now they're telling us that use the first 3 terms evaluate root 8. Now root 8 means that they're talking about the square root. Now I deal with square numbers. The real reciprocals. The first square number is 1. The next is 4, which is its reciprocal is that. The next is 9, its reciprocal is that. The next is 16, its reciprocal is that. Up to when you reach and so on. Why am I now dealing with the square numbers? Because I'm dealing with the square root of 8. Now, of these ones, what this thing we can put here to get the square number we want to get. Now, you see this one is already having a third in its 1 over 3 in its denominator. So it means that now, if I compare now this with any of these ones, like if I compare now this and this, you see, to get 8, I need this to be a 9. So it means that now, if I compare now my x over 3 with 1 over 9, because if the whole of this is 1 over 9, it means when I cross multiply, I'll be having 9 minus 1, which will give me the 8. So you see that from here, our x should be 1 over 3. But you see that we are dealing with the square number first. So if I put it here, if my x now is 1 over 3, allow me to use a duster here. So if my x there, if my x is 1 over 3, this is going to be now 1 minus x, x is now 1 over 3 as you see there. So if I allow this, it's going to be now 1 over 9. If I put it here, it's going to be 1 over 3, which will give us 1 over 9. Equaling to 1 minus, where there is x, we put 1 over 3, over 6 minus 1 over 3, the whole squared over 72, plus other terms having like that. Okay, now there, we simplify. So here, if you cross multiply, you have 9. minus 1 over 9 power a half. Why do we deal with square numbers? Because when you get their square root, you get a positive integer, which is perfect. So this is going to give us, okay, let us put this on the calculator. This is what you get. You have now, this is going to be 9, then 72, 1 divided by the answer, minus 1 over 18 plus 1. So here I'm getting 0.9429. So now, you see now this will give us 8, the square root of 8 over a half is the square root of this 9, approximating 0.9429. From there, so now shall get root 8 over square root of this is 3, approximating 0.9429. Alright, cross multiply. If I cross multiply, so now my root 8 will be approximating to 3 times 0.9429. So now my square root here of 8 will approximately be, you get that value, then times 3. Then I'm getting 2. They are telling me, I'm just evaluating, so I'm getting 2, 8, 2, 9. I'm giving this 3 decimal places. Now, the question is not restricting you to how many decimal places we're giving at that. Now, to classify your answer, you have to check. When you press this on the pattern, you get a corresponding value to that, and that's how we get that. Now, when you grab this is binomial, we are going to show that this is this. What we do, we expand this first. So they are summing two things x. They are summing this and this. So you first get this. Now so they are ending at x squared. These are also going to end at x squared. So now our half is the same as our square root. So can we expand? We have 1 plus n, which is our half, into x, which is 2x. Then plus our n is our half. Reduce it by 1, get negative half. Then this will be 2x, the whole square, over 2 factorial, plus other terms. I'm substituting in that formula. Why? Because start from here, my n is a half, so that my x is 2x. So, to simplify this, 2x power half will be 1 plus x. Then you see that we are going to be adding, this is going to be 4, which is going to cancel this. And we have this factorial, so we have x squared over 2 plus other terms to simplify. You see 2 times 2 is 4, so the square 2 will get 4, so this square is going to cancel. But we have 2 factorial. 2 factorial is the same as 2, that's why you have this. So that, when you turn out this root of 1 minus 4x power half, we shall get, you see that from here, our n is a half also. So n a half. Now our x here is negative 4x. Then plus a half. Then a half minus 1. N minus 1, which is a half minus 1. We get negative a half. Then our x, negative 4. X squared plus other terms coming. And all of this and 2 factorial. So now our 1 minus 4x power half, it will be, you see we have 1 minus, this is going to give us half of this, 2x. Here what are we getting? Are we getting a minus? Okay, when this times this is going to give us, first of all, we have a minus. This is going to be minus and this minus. Remember, in square, this will get a positive. So we have a minus. This times this, we have 4. This is going to give us 16. And this is what I'm going to survive with. I'm going to have now, this step is going to be negative 1 over 4 times this half for this 2 factorial. Then times this is going to give me 16x squared. And so this will give me, this will be 8 2x squared. So minus 2x squared plus other terms coming. Now, when I add these two, when I add 1 plus 2x power half plus 1 minus 4x power half, I will get now, this is 1 plus x minus x squared over 2, of course, plus other terms coming, and plus 1 minus 2x squared plus other terms coming. You see that now what I'm going to get, this one plus this one, we get 2, then x plus minus 2x, get negative x, then negative half minus 2, we shall get negative 5 over 2x squared plus other terms. And we have shown that the square root of 1 plus 3x plus the square root of 1 minus 4x is equal to that, like that. Then using x, taking x equaling 2, now here I'm not going to compute